Hello again. I'm going to do another trig proof in this video. Here we have sine of 2x divided by sine of 1x minus cosine of 2x divided by cosine x equals secant x. I always encourage us to go ahead and draw our boundaries so we know not to cross over or move terms from the left to the right. So I'm going to work solely on the left, and I'm choosing the left because it looks more complex than the right. All right, so I see some identities that I could plug in here. Sine of 2x. I have a sine double angle identity. Hopefully we all are recognizing that sine 2x is equal to 2 sine x cosine x. So I have that over as sine x, and I see something is going to cancel. I'll do that in a second. Now, we have a cosine 2x, and there are several cosine double angle identities that we could use. I've got cosine of some double angle 2x. I don't know, my pen is being funny and skipping while I write. Sorry about that. But we've got cosine 2x, and there are 3 cosine double angle identities. So one thing I might consider is what is in my denominator. And in my denominator here, I have a cosine. So when I cancel over here on the right, notice those signs are going to cancel. I'm going to have a cosine. So maybe out of my 3 cosine double angles, I'm going to choose 2 cosine squared x minus 1. And I chose that with some careful thought. That doesn't mean that using the other 2 would make this wrong. It was just, this is going to give us less steps, so we'll be following a path of least resistance, if you will. All right, so as we noticed, those sine x's are going to cancel on the left. So I have 2 cosine x. On the right, I have 2 cosine squared x minus 1 over cosine x. Since there's only one term in my denominator, I'm going to unadd these fractions. So that's negative 2 cosine squared x over cosine x, and minus a negative, that next term would be plus 1 over cosine x. So nicely I can see that that cosine in the denominator is going to cancel, and now I have 2 cosine x minus 2 cosine x plus 1 over cosine x. 2 cosine x minus 2 cosine x is 0, so that cancels. I'm left with 1 over cosine x. And is that equal to what I'm trying to get? Secant x? The answer is yes, it is. So I'll do one more step to show that they're equal, and I've got secant x equals secant x, and I'm done. So I end it with a therefore. Since this was such a short video, I'm going to do a second example in this video. For our second example, we're going to prove this identity to be true. Secant t minus 1 divided by t times secant t. We need to show that that is equal to 1 minus cosine of t divided by t. All right, we got to pick a side to work on. Generally, we try to pick the harder side, and remember, we can work on both sides, but I find, especially when I'm teaching this or when students are learning, it's helpful to try and stay on just one side of the equation. So I'm going to pick the left. I think the left is more confusing because we've got these secants in there, and cosine on the right is easier for me to deal with. So my first thing I'm going to do is turn secant into cosine. So now I have 1 over cosine of t minus 1 divided by t times secant t is going to become t divided by cosine t. So I rewrote everything as a sine or cosine. In this case, everything as a cosine. Now, remember, I'm dividing by this value, and division is the same as multiplication by the reciprocal. So my numerator, 1 over cosine t minus 1, I can multiply that by the reciprocal of that, which would be cosine t over t. So copy, change, flip. Now, I have two terms in my numerator, so I need to make sure I have parentheses there to remind me that this term, as I'm simplifying and carrying out my algebraic operations and manipulations, it's going to distribute. So I'm just working away. I have 1 over cosine t times cosine t over t minus cosine t over t. All right, so let's look back up at where we were. We have to have 1 minus cosine t over t. 1 minus cosine t over t, and that I just pulled down. So looking at this problem, my cosines cancel. I now have 1 over t minus cosine t over t. And those two fractions have the same denominator, so I can add them together, and I've got 1 minus cosine t over t. And now both of my sides are equal. We're done with this problem. We'll write therefore, the end. All right, good luck out there. You're on your own. Be safe and have fun. Email with questions.